All right, so my name is Fola Shoboejo, and I work for Kroger as a software engineering manager. And a lot of things I do with machine learning is actually things that I do outside of work. Now, there are some things that are sort of related because I do a lot of things that intersect with data, but it's a lot of my exploration is something that happens outside of work. I also have the privilege of actually helping organize the machine learning meetup in Cincinnati, which has been great. So if you're ever in Cincinnati on the third Thursday of the month, you should definitely check us out. Go to meetup.com. You can definitely learn something about it. All right, so let's go ahead and jump into it. So how many people here have heard of the 10,000 hours, 10,000 hour rules? All right, good. So Malcolm Gladwell made this popular in his book called Outliers. And to the detriment of many, with a lot of benefits of explaining what 10,000 hours is, I'll just go ahead and summarize what it is. It's basically this idea that if you're going to be an expert in any domain, you need to have 10,000 hours invested in a specific skill, right? And that can be very discouraging because for someone like me that has tons of interest, I don't have tons of 10,000 hours to invest in every single thing I want to pursue. So first thing I'm going to say is don't panic. I'm not going to tell you you need the 10,000 hour rule to actually be able to do something practical and tangible with this. And in fact, I'm going to tell you that with the way, my journey specifically with machine learning, I did not need 10,000 hours to actually do this. This was one of the first things I actually worked on that has some intersection with machine learning, where I built an energy monitoring application at home where I could tell how much energy I was using, what days of the week I was using the most energy, as well as what time of the day. The interest stretched a little further because then I became genuinely interested in knowing, well, what if I left my stove on or I left my iron plugged in? I don't know if that ever happens to any of you that think about that when you're on the trip. But it crossed my mind, and in order to do so, I wanted to be able to detect anomalies in such events. So Kibana, which was the visualization tool that I used, had a module for capturing anomalies, which in this case was my first foray into this. The other thing that I did I was really interested, and once again, I did not need 10,000 hours to do, was working on building a recommendation system. So I have kids. I know some of you probably do here, 6 and 4. The older kids are 6 and 4. Actually, I have a 6-week-old too. But my older kids, the 6 and 4-year-old, finding something for them to do during the weekend can always be a challenge. And for me, I was really interested in, is it possible for me to create a sort of recommendation engine such that when I type in the name of a place of interest, it might display things that maybe are similar to things that my kids might like. Something I probably spent way more time than I'm proud to say on is also with fantasy football. I don't know if any of you that are fantasy football here. I got suckered into doing it with my coworkers about 5 years ago. And my first year I was terrible. I was terrible. I didn't know what I drafted 3 quarterbacks. I really didn't know what I was doing. But subsequently, I decided that, well, we have a wealth of data in this domain. Is it possible to apply some statistical analysis or some machine learning algorithms to be able to help me in my drafting as well as in my in-season decision making? Well, I'm proud to say that I came first in my league this year and second last year, but I probably can tell you that I can't necessarily give all the credit to machine learning. But it was interesting to kind of see the things that I could actually do and glean from data, once again, not requiring 10,000 hours to be able to do that. The interest that I have maybe the most keenly right now is around the area of text summarization. I'm going to talk maybe a lot about this more a little later, but I said to myself 2 years ago that, you know what, I need to focus on one domain of machine learning. It's such a wide space and such a wide domain, and so natural language processing became an area of interest for me. And I worked towards building a text summarizer because my interest was in, well, I read a lot, and I have a lot of articles I want to read, but I don't want to take time to read the whole thing. So is it possible to take a body of text, put it into an application, and basically squish it down into something that is readable and makes sense to me? So I was able to actually build this. This is actually deployed out in production if you want to give it a test. And just to kind of add to that specifically, I probably don't have enough of these here, but I figure that people might be taking notes or maybe trying to capture pictures. So what I did was I printed out some orange sheets here in front that have a summary of everything I'm talking about, including some things I'm thinking that I might not get to. So for those of you not in this room right now, I apologize. You might not get a copy. I do have a blank sheet at the end. You can just fill out your email address or contact information, or you could just reach out to me on LinkedIn if you want a copy of the sheet as well. So I have this in production. I use an extractive approach, an abstractive approach, which I don't want to get into some of the lingo right now, is what I'm working on currently, is where you take a body of text, you summarize it, but you generate new words that are not in the actual body of text itself. It's almost like what you and I might do if you paraphrased a document. But once again, I did this without having to invest 10,000 hours. So there's hope for anybody and everybody here interested in pursuing machine learning as a whole. So I want to talk something a little further. I'm sure many of you might be aware of the Pareto Principle 80-20 rule that basically says that 80% of the output or outcome can be explained by 20% of the input. I'm saying it in my own simple words. My goal today is to give you what I believe is the 20% you need to be able to get 80% of the way. Right? You can spend a lot of time and invest in your time in a lot of things that might be able to try and take you through actually being a practitioner or being someone that is well informed on this topic. But I really want to streamline it down and say, hey, here's the 20% I think. Spend the next 4 to 6 weeks on, and I can give you a high level of confidence. You can start to see things that give you that sense that you're becoming more of a machine learning practitioner. Don't worry, it's not a get-rich-quick scheme. It's nothing I'm going to be selling here specifically. But I really think that we don't often think about, when we're learning a new skill, we don't often ask that question, what is the 20% I need to know that will take me 80% of the way? So the first thing I really want to bring out is this idea of choosing a path. The fact that you're here right now means you've decided not to be in the other sessions. And we often don't think about decisions and choices in that way. When you say yes to something, you're saying no to everything else. And so the first thing I really want to address is that question of, if you really are interested in becoming a practitioner in machine learning and you want to do something tangible with it, the first question is, what is going to come off your plate? What are you saying no to? If you're saying yes to this, what are you saying no to? Because if you don't start there, you're essentially setting yourself up for not being able to succeed at all. So it's something to chew on. You might not have that answer here before you leave, but I think it's something to be mindful and to chew on is, what do I need to say no to if I actually want to embrace this? You can't do everything. You can do a lot of things, but you can't do everything that you want to do. The other thing I think is also worth calling out is the distinction between what I term literacy and actual competency. I believe literacy is this idea of learning to know, right? And competency is learning to do. I think that's something that's also worth assessing, because having literacy in machine learning might just be satisfactory to you. Maybe you're a business executive or you're a manager, and you just want to be informed about what is happening in the domain of machine learning to make informed decisions in that area, right? In that case, you want to learn to know. But if you want to be a practitioner and you want to gain competency, you need to learn to do. And the reason why I call this out specifically is that this shapes the choices you make in terms of what resources to use and what resources that are best beneficial to you. In fact, when you come across any course, any material, any article, the question you should ask yourself is this helping me be more literate, or is this helping me be more competent? So it's important to understand that distinction. And if your desire is just literacy in the domain of machine learning, you know what? That's fine. But understand the difference and what that distinction is. The other thing I think is worth also making assessment to, and I wish I could take a poll right now for everyone in this room and in the other rooms, is we're all starting from different places, right? Some people here have science backgrounds and science degrees. Some might have humanities. Some might have business and accounting. So we're not all starting from the same place. For someone who is a programmer who's done Java development, JavaScript development, you want to pick up something like Python or R, you have an edge, an advantage. And it's important to kind of be mindful of that, is where am I starting from? And also, where am I going? Is your intention to be a data engineer or a data scientist? Is your intent to actually be someone that works on creating and researching algorithms? Or is your interest in building products that actually use machine learning capabilities? I think having that distinction in your mind in terms of where am I starting and where am I going is very, very critical because it shapes your journey, right? And you taking the same course as I'm taking might not provide the same benefit. It also helps you carefully evaluate the question, what is the best course I need to take for machine learning? The answer a programmer might give to you might not be the same thing as someone who has a humanities background has. Something to keep in mind and to be mindful of. Something else I think that is worth keeping in mind is this question of, are you someone who loves to look at what occurs under the hood? When I was a kid, I was that kid. I'm sure there are many people here like that took apart all their toys because you wanted to know what happened underneath your toy. Unfortunately, I was one of those kids that didn't know how to put my stuff back together, so I had a lot of broken toys as a kid. But the reality is that, especially for engineers, there's this curiosity of, I want to understand what's going on. In fact, I know an engineer who says, I will not use a framework until I understand what happens under the code. All right, so how many of us have cars? How many of us came in cars today? Can I just see your hands up? Came in a car, all right, cool. I'll ask one more question. How many people have had your oil changed over the last year? Okay, pretty much everybody? All right, now this is going to maybe streamline it down. How many people actually did their oil change themselves? That's a good number. That's a good number. A little more than I was expecting, but some people did it. Now, the fact that you did not do your oil change yourself does not make you any less a driver. You still have a driver's license. You're still a good driver. And the fact that you being able to drive a car does not require you to understand what a spark plug is or how a transmission works. Why should that be any different when it comes to machine learning? It all depends on your outcome. There's this misnomer, I believe, or misassumption that for me to be a practitioner or for me to be able to get my driver's license for actually doing something with machine learning, I have to be able to understand everything that happens under the hood. And so that leads to a lot of courses. You see a lot of materials online. Hey, here are the skill sets and things you need to do to actually be able to do machine learning. And then you say, oh my goodness, this is going to take me a year to be able to do, right? So I think it's something to be mindful of. Now, there are some disciplines that require you to understand the fundamentals, right? Medicine is an example, civil engineering. If you were in a surgery and your surgeon came in and was like, oh yeah, I just got done watching 3 YouTube videos on how to perform heart surgery. I think we're ready to go. You're like, you're not going to touch me, right? Because that discipline requires an understanding of the fundamentals from the bottom up to the top. But that is a little different. There are some disciplines, and this is an area. So I want to maybe flip some things over the head in terms of what you've heard about machine learning and how you approach it, because I feel like there's a way you can approach it differently. I think I'll tell you a story to kind of maybe draw this out a little bit better. When I was a kid, I took music lessons, and primarily piano lessons. And I don't know if this was the experience for everybody, but my music teacher taught me like basic music, but was having me learn bass clef and treble clef. And no kidding, for weeks on end, had me drawing a bass clef and a treble clef. What in the world was I going to do with that to actually do with music? Now, for someone that appreciates music theory, you might look back and say that makes a lot of sense. But as a kid, 6 weeks in, I lost all interest. Because I was like, I'm not playing any music. I'm not doing anything with all this knowledge I have. Because the assumption is learn everything you need to know, then you can actually do something with it. When I went into college and I learned to play the guitar, I would say I'm self-taught in a way. It was a totally different experience. I basically had a couple of friends that played the guitar. I got a guitar, right? I needed a guitar to practice. And I said, what do I need to know? He says, well, this is how you hold a guitar, right? Here are 4 chords that you need to learn, and this is how you strum. And in a matter of hours, I could listen to music that I wanted to play along with and feel like I'm sounding like the person on the actual playing the guitar in the song. Now, that was different feedback. That did not require me to understand every single key, music theory, chord progression. It was essentially an approach of learning things top down. What is the song? And what do I need to know to be able to actually play the song over time? What I'm explaining to you, or what I'm presenting to you, is a top-down approach versus a bottom-up approach to actually learning, especially when it comes to this. And I would dare say that a top-down approach is probably going to take you a little farther and faster to what you actually want to do and achieve. And a case in point, when I first learned, when I was asking people about 5 years ago when I was getting interested in machine learning, they were telling me, well, you got to go check out Andrew Ng's course on Coursera. It was really the course, right? That was the go-to course at that point in time, and I think it's still a great course. But I spent a lot of my time going through a bottom-up. There were things I was learning there that I really didn't feel like were contributing directly to actually being able to do something. Now, I think it's a great course, and I think when you're further along, it makes a big difference. So there's a difference in approach, the top-down and the bottom-up. The bottom-up approach assumes you have to learn all the theory, you have to learn all the linear algebra, you have to learn all the calculus, you have to do all that down before you can actually do anything with machine learning. And I would challenge that. In fact, I tried that approach on some of my coworkers who are here today, and they will know that about 3 or 4 or 5 weeks in, they're like, forget it, I'm not coming back to this anymore. So I know it doesn't work effectively. In fact, the times when I've had the biggest leaps in things I've been learning is because I started with a song. I started with a problem. I started with a project. Same thing like the energy utilization. The fantasy football, I started with a song, and I said, what do I need to learn to be able to do this and make progress in that space? David Perkins is a professor at Harvard, and really promotes this idea. So if you want to Google and search it online, he talks about it, the whole idea of playing the game. The way you learn to ride a bicycle is by riding a bicycle. You don't have to learn about the wheel, the physics behind it. You just want to ride a bicycle. So it's that whole idea of being able to get it done and learn things on a needed basis. So this is talking about the approach, right, in terms of how you want to walk through it. Now, you might get through this and make a little bit of progress like I did with music and playing the guitar, but there was a time where I needed to make advancement. And there's a time that comes where you have to, like, essentially play in the discomfort zone, right? There's a time where you have to fill in the gap and you have to get better at what you're doing. In that case, learning the circle of fifths. You know, for me, I don't know how many of you are music people here, but when I learned the circle of fifths, it blew my mind. I was like, wow. I was actually able to compose songs in ways I never thought before. I was playing a lot of bossa nova music, jazz music, understanding chord progression. If I had started there, I bet you I wouldn't have gone very far. But when it came timely, within the right context, I was able to embrace it. So there's going to be a time when you need to learn, how do I get and clean this data myself? How do I deploy this model into the cloud? You know, how do I scale this up and actually move from the command line, from a Python notebook to actually command line? There's a time and there's a place for it, but I'm telling you, you don't have to start there, right? And I think that's a misnomer in terms of instructions and information you find as far as machine learning goes. All right, so you came here to kind of know about resources. Someone actually walked up to me here before I left to say, hey, what resources and what books can you recommend for me to check out? I'm going to get to the books a little later. But let's talk about this. What resources would I recommend? I would say is part of the 20% that if you invest the next 4 to 6 weeks in, can really help you start getting some about literacy and that practitioner experience you're looking for. Well, to make the leap, I would recommend first and foremost Fast AI's Introduction to Machine Learning course. They also embrace this idea of a top-down approach. You know, from the first lecture or lesson, you're already building things that require, computer vision using convolutional neural networks. Now, the disclaimer here is that Fast AI is really built on this idea of deep learning. So if you're interested in deep learning, and I will kind of clarify what that is shortly, Fast AI, I don't think there's a course that beats it. Udacity also has a great machine learning course. The reason why I like the machine learning course, and I don't remember the exact number, is every other algorithm outside of neural network, it gives you a chance to actually learn about that, from support vector machines to naive Bayes to k-means and k-clustering. In fact, a lot of the algorithms that I used for my fantasy football analysis were not neural network based at all. So I think this course, if it's still the same course the way it was when I took it about 4 years ago, I would say it's a great course for you to explore. Now, for literacy, I find that as a blog, and I don't remember the guy's name. Some of you may have seen this before if you do a lot of reading in machine learning. Is a series. He has a post series on Medium called Machine Learning is Fun. This is a great, great blog. I mean, I just tell you personally, like if you go through the material, conceptually you can understand what's going on. And the reason why I put it on the category of literacy is when you're done reading it, you could probably explain to your friend and say, this is how a neural network works. But guess what? You don't know how to do it, which is fine, which is okay. I think literacy is important, in terms of building competency. I'll recommend that as a good resource for you to check out for that purpose. Also very useful if you want to get into the meat of neural networks is a deep learning book. I think it's by Ian Goodfellow. I'm not quite sure. I can clarify and provide that name for you afterwards. But if you just Google deep learning book, it's probably going to be the first result. It's an actual web page. If you want to download the actual version, you can actually buy a hard copy and all. But the online version should be fine. Those two resources, I think, are great. Now, YouTube can be very helpful, and I wouldn't spend a whole lot of my time watching a lot of YouTube videos. I think there are two people that I would say 40% of what I know and I can do in machine learning, I glean directly from them. Siraj Raval, as well as SenseDex. I think those two folks, I think they know what they are doing. Not only do you get to learn about the programming languages, but you also get to walk through examples as well. So once again, I have orange sheets here. If you're worried about taking notes or whatever, I can give that to you after the fact. All right, and Corey Schaefer comes highly recommended as someone, if you want to learn the Python programming language, that's someone you definitely, his resources is highly recommended in that space. Take just his resources, 4 to 6 weeks, just for the next 4 to 6 weeks, try it out. If you don't see any progress, I can't really give you a disclaimer. You should let me know. I owe you a cup of coffee, I tell you. Because I really think that these things could really help you make that leap and bound where you need to be. As far as programming languages go, I think the main players here are Python and R. And I'm not even going to play with you. I'm just going to say go with Python. I know for the R lovers here, I know you're probably going to be upset with me. But if you're brand new and you don't know what you're doing and you want to get started, Python, there's nothing that beats Python. I also have reasons why this beats everything else. Second to Java and JavaScript, I think Python is probably has the highest commits to GitHub. It's also a very fast rising language. C++ keeps wanting to come back. I don't know why, but I would say Python I'll recommend Python very highly. There are a couple of tools and packages you might want to get familiar with that could be very helpful to you. In fact, I believe there's a talk later this afternoon on Jupyter Notebook dealing with machine learning as well. You should definitely check it out if you want to learn about Jupyter. But these are the resources that you're going to be playing with day in, day out. I probably have 1 or 2 well-known libraries left out, but these are the big boys in terms of what you need. And those primarily have a lot of support with Python. As far as actual framework to use, like a library or framework to use to actually start doing real machine learning work, Scikit-Learn, I think, is probably the best. It's not one of the big boys when it comes to deep learning, right? But if you want to do something basically, in fact, I think the example I'm going to be showing a little bit I'm actually using Scikit-Learn for support vector machines. I think there's nothing that beats it. Not only do you have like data you can work with inbuilt into it, but it has a slew of algorithms already available for you to use. And then as far as it comes to the big boys in terms of deep learning and that sort of thing, I think these are the best choices you have. Now, if I was to recommend to you, I'll just say go with Fast AI, right? But that means you're probably taking the Fast AI course to know how it works. If you don't and you want to work with something a little bit more underneath, I would say PyTorch. Fast AI is actually built on top of PyTorch. Keras is also really good, and surprisingly enough, personally for me, TensorFlow is kind of at the bottom. TensorFlow is really good, I think, for people like that picture I showed you, the person that is under the car, who has controls of every nitty-gritty detail. I think TensorFlow is great for that. But if you're someone that said, I just want to get started, I just want to do something tangible, I would say PyTorch and Fast AI are probably great choices for you to go there. The usual suspects in terms of where you could run this, GCP is my go-to now. They have like Jupyter Lab, which is basically an easy way for you to spin up a Python notebook. I do a lot of my upper scaling model running on there on GCP. I wrote some articles in the last 2 months, and I think I have links in them to basically how you can set this up. I actually might have it in the orange sheet as well. Paperspace is actually an interesting one that I came across recently. I'd only used it barely, but it's good. If you're concerned about running an algorithm on your computer, it gives you the hardware for you to do that. I tried running some clustering analysis on this baby, and it honestly ran for the whole weekend. I had to leave my computer open the whole weekend, and it was just chugging, and still, it didn't get there. So at times you need like some cloud solutions to explore. I think these are good ones to use. Then you need data, right? You need data to actually do something useful and tangible. Don't waste your time trying to look all over the internet. I think these resources are sufficient for you to get started. Now, a lot of packages come with inbuilt data already, but between Kaggle, UCI, FastAI has some reference data sets as well, and your own projects. When I did the energy monitoring project, it was the data from my actual house. I was actually monitoring how much energy I was using. So it was actual data coming from my house. So you might be able to generate your own data, which is even better. Now, I believe very strongly that to achieve success, there are two things you need. And everything I've told you up to this point in time has to do with only one of them. So if you walk out right now, I think you might be confident getting out one thing, but I think this other aspect is very critical. So what is important for success? I believe success is a blend of experience and motivation. Everything I've told you so far can give you the experience you need to actually start making some progress. But you need to figure out the motivation bit. And that's what I'm going to talk about right now. Now, some of you are familiar with Simon Sinek, starting with the why. If you're not in the club, you can go ahead and check it out during the break. It's a great TEDx video on starting with the why. That's not actually what I'm focusing on here. But I think it's important for you to identify your motive and your reason for actually wanting to get into machine learning. And the reason why I think it's really important is because when Stranger Things comes out July 4th, and it's Friday night and you want to watch the watch the series, or binge watch it, it's your motivation and your why that's going to say, you know what, I'm just going to finish up my model and get what I'm doing done so I can make some progress. Those days when you feel like you could be distracted, it is your motivation that's going to help you. And I find a lot of people that start with machine learning because they didn't quite get that why down, or they were not quite clear in their mind why they were doing it, you lose motivation. You don't get very far with it. So let's talk about that real quick. I believe there are 4 things that potentially could play into this area. And I think one motive is I want to stay competitive in my industry, right? I don't know how machine learning is going to be a big deal. Is it going to be a skill that everybody needs to learn or know how to use? It's not just us asking that questions. I think nations are asking that questions. I don't know how many of you are aware of this or know this, but China is right now on track to actually surpass the United States in terms of machine learning publications. Now that's a big deal. The reason why it's a big deal is a lot of not necessarily new discoveries, but a lot of novel applications of algorithms are being published at scale from China. And so the United States is like, yo, you can't leave us behind. And so the president earlier the year gave like an executive order, say we're investing in artificial intelligence. Now that's yet to be seen, but the reality is on a nation level, on a nation scale, there's already some concern and thought is how do we stay competitive, right? And so for you in your work and the things that you do daily, the question is, I want to stay competitive. I want to stay competitive in the market, in the industry. Can machine learning help me have that edge that I need? Another reason why you might want to pursue it, another motive for you could be, I want to increase my productivity. I want to be better at my work. You know, you could be a chemist, you could be an accountant, you could be someone that works with stocks, and you're like, well, I want to better be able to do my work well. Well, Salesforce, I believe through their Einstein application, this is based on a research paper that they worked on, and I was talking about text summarization earlier. They've actually made some advancement and progress in terms of abstractive text summarization, where you analyze a huge body of text and basically picking out the most important things in it, right? It increases productivity. Think about your sales rep. They don't have to read the whole email, a customer email. They could just read snippets of it, right? It increases productivity. You might also be aware, I don't know, some of you might be, but Google has Google Compose now, or Gmail Compose, where I'm trying to type up an email and it's auto-completes my sentence. Not even it's not auto-correcting, it's not predicting the next word I'm going to say. It's like my whole sentence. I don't know, how many of you have actually used that? I use it all the time now, and guess what? The person on the other side doesn't know because they also used it too. So the interesting thing about it is this increases productivity, right? So you could be thinking that the reason why I want to use machine learning is to increase my productivity. Maybe you're on the site reliability team, and you're like, we're having a lot of hacks, and we need to be able to detect traffic that is legit or not legit. what can we do with our data? Log data. How can I analyze the log data? Or you could be a taxonomist, labeling a lot of data and products, and like, you know what? I want a way to kind of cluster all this information together and auto-label it. Increasing your productivity could also be a reason why you pursue this. I think something that's also worth paying attention is the question of being in the driver's seat. And what I mean by that is the reality is that with the advent of predictive analytics, who gets to see an ad or who gets to get their loan approved is dependent on this machine learning, right? A lot of algorithms are actually driving decision making in this space. And so your thought might be, you know what, I want to be in the driver's seat. I just don't want AI to happen to me, right? I want to be in the driver's seat, and so I want to be able to influence that or have a voice in that domain, and that might be your why, right? I'll give you a good example is how it leads into this whole idea of bias, right? If you're not in the driver's seat, the question is, could I be subject to bias? So this is there's a software that has been used by law enforcement across the United States. And basically the job of the software is based on criminals that are taken in, right? They basically try to predict who is high risk or who is low risk, right? In terms of committing a subsequent crime. So some people, if you're a 10, you're like, oh, for sure, you're gonna do it, right? And if you're 1, maybe I go easy on you, right? If this sounds familiar, maybe it's a little bit because maybe you've seen Minority Reports and you see that predictions are being made on who's gonna commit a crime. And this is just one step closer. I'm not trying to scare you, right? But the reality is some of these things are out there. But if you go ahead and see in every single one of these cases, 2 years after the fact, the person that had the highest score, 2 years later didn't commit a single crime. The person that had the lowest score went on to commit subsequent crimes. Now they are paired based on being arrested for similar offenses. Now this is real bias. Now, I don't know how much decision making was being made based on this information and data, but that's bias right there, right? And so your reason for why you're getting into this might say, you know what, I want to have a voice and I want my views represented. I want to be represented, whatever that might be, or I want to help influence something one way or the other. Another good example is this language translation, right? You go from English to a different language, and when you take it back, you see the genders are reversed. All of a sudden, it's not she's a doctor, it becomes he's a doctor, right? It's no longer he's a nurse, it now becomes she's a nurse. So these are things, the people that created this or creating these applications and solutions are not saying, I want this to be the bias or I want this to happen, right? They are doing what they think should be represented or to solve a specific problem. But the reality is the data that is collected and how it's used without having a good representation could lend itself to bias. So this might be your reason. This might be the thing that says, you know what, Stranger Things, I'm going to defer you for the next 2 weeks so I can finish this text summarization application or whatever it might be. Your motive is also very, very important, and that's what I wanted to highlight there. So now let's back up a little bit. How did we get to where we are? So first thing I would say, and what you'll probably hear from a lot of researchers, is that there's really very, very few algorithms that are actually brand new in the space of machine learning. We're talking about things that have existed in the 50s. In fact, if you go read or research text summarization, you're probably going to be starting with papers that were written in the 1940s, right? So there's really nothing groundbreaking in how you approach it. The difference of what has happened between then and now is primarily based on 2 things. One, the volume of data that we have today. Right? I don't even know how it can be quantified, but think about it. I mean, a few years ago, did we have YouTube? 10 years ago, did we have YouTube? Right? Remember, how many people remember using MapQuest and not Google Maps? Right? Your wearables, all that data being on Facebook, social media, Twitter. There's so much data now available that you can actually look for signals in the midst of the data. That's one. 2 is actually how you process that data. The advent of CPUs and GPUs make it easier for you to process a big chunk of data. And if you notice, every 30 years, now I'm not making a prediction here, there's always been a groundbreaking change. And you would notice that, we started with AI, artificial intelligence, and then we moved into this realm of machine learning and then into deep learning. So if you were to try and classify them, deep learning is a subdomain of machine learning. Remember I said there are other algorithms outside of neural networks. And then machine learning itself is a subset of AI. Now, you might say, what's the distinction? Real quick, I'll just say AI basically can be artificial intelligence based on rules. So if you have a bunch of if-then-else statements or rules or decision trees, you could have that as a way to say that's artificial intelligence. The difference is with machine learning is you are actually making decisions based on approximations. You are using statistical models to make approximation of a decision. So you're saying, I'm 90% sure that's a cat. Right, so that's different. It's not rule-based. It's not saying if it has a nose, if it has 2 ears, if it has an eyes. AI used to be in that fashion before the advent of machine learning and deep learning. Algorithms that I think are worth knowing. So if you wanted to create like a checklist for yourself to say, hey, what algorithms do I need to know? I would say these are some that are worth knowing. Useful neural networks is there, yes. But these are just some. I've used quite a bit of them. There are a lot of things you can actually do with these, but I would say these are 10 algorithms that I think are worth knowing, and once again, it's also on the orange sheet. All right, so machine learning as a whole, there are 2 key kinds of problems you're trying to solve when you're dealing with machine learning. Right, not classes of problem, but there are 2 ways in which you're approaching machine learning. You can actually do this in a supervised version or an unsupervised fashion. Supervised basically is the idea that I have a set of inputs and I know what the outcomes are. And so I train a model to say, here's input, here's output, here's input, here's output. Try and figure out the relationship and the pattern that connects them together. Oh, now, by the way, I'm showing you a new input. Now I want you to tell me what you think that output is going to be. So that's supervised, right? Because you have that output there that you're using to train. Unsupervised basically just like you give it a chunk of data and like, you know what? Just tell me what you see. Right? Just segment this data for me and tell me what you notice, right? So there's some algorithms that are geared towards unsupervised and some that are geared towards supervised. Now you can make a point for reinforcement learning and things like that, but these are the 2 general categories that you might see. Now, for any of you here that is interested in being a practitioner, or maybe something here or something you read before inspired you to say, I want to start a startup, I want to build a product using machine learning. Well, Andrew Ng, who is well known in the domain, says that 99% of economic value today lies in supervised learning. So if you are trying to decide, okay, where should I start? What kind of problem should I solve? If I want to build a product that people want to use, you might want to explore the domain of supervised learning. Supervised learning itself can be broken down into classification problems or regression problems. The difference being a regression problem is saying, can you predict how much that house is going to be? Right? You're looking for a specific number. Or can you predict what my score is going to be on my physics test? That's like, is it going to be 77? Is it going to be 80? So it's a number. It's like on this continuous, right? But classification is basically, right, is it a cat? Is it a dog? Is it a 9? Is it a 4? Is it a 3? Is it a 2? You basically have classes, and you're trying to use the model to say, what class does this thing fall into, right? Everybody get that? And then there's clustering, right? Clustering is what you're essentially doing when you have unsupervised learning. Now, you might be thinking and asking yourself, well, this is all well and good. Is there still a reason for me to actually want to explore machine learning? Well, the reality is, resistance is useless. And that's because whether we like it or not, some of you have probably used some of these products recently. I was one of those that got suckered into watching Bird Box over the winter holiday. And if you've used any of these products, the reality is you're using recommendation engines, right? There are a lot of products. If you've used Google, Gmail, all those things have machine learning back in them. And the new world that we're going into is one in which you're going to have a product powered by machine learning, right? But artificial intelligence is not always so intelligent. It doesn't always get it right. If you read the text exchange there, the autocorrect doesn't always get it right. I don't know how many of you this has happened to, but it happens to me a lot, where you have to correct it. So artificial intelligence is not always so intelligent. But guess what? We don't always get it right too, because the text exchange on the other side basically is alluding to someone who doesn't really understand what LOL means, right? And they used it in a way that was not supposed to be used. So there's that aspect and that element of, what role does artificial intelligence play and how can it help us do what we want to do. There's several applications for machine learning. I could go on and on. These are just ideas of things that you might say, you know what, I want to pick this problem. Remember I said start with a song, right? Start with a song, find a problem and you want to solve. Don't try and say I want to be a machine learning expert and I'm just going to go learn calculus and linear algebra. I took a linear algebra course for 12 weeks and the only thing I can remember is an eigenvector. Which is cool to say, but I really don't even know how to use it, you know? I kind of do, but it's kind of funny, right? So pick a problem. Find a specific problem or domain, and if you don't, there are many problems out there. You can Google, you know, machine learning problems to solve. Pick a problem and start with a song. A great book I would recommend is this one by Kai Fuli. He was on 60 Minutes a couple of months ago. If you don't like reading the book, audiobooks, yo. So that's the way I go. And, you know, it's a great book, but I think it just gives you literacy. Once again, you don't come out being able to do anything, right? But one thing it does is it keeps you informed. He's an investor who has worked both here in the United States and in China as well, and he knows about things that are happening in that space. Talks about things about the implications of AI in terms of redistribution of wealth, retraining workers, people losing jobs. These things are going to have impacts in our lives. So if you want to be more literate on this topic, this is a great book to do that. If you want to learn to do, right, I think for me, in my opinion, this is probably one of the best books I have come across to do that. Now, there are many books. I have another book on machine learning I would not recommend to you. There are a lot of good ones out there, but this is a great one, and it's not necessarily focused on machine learning. Just talk about the idea of collective intelligence. I think it's a good material that helps you begin to think in terms of intelligence and how you build intelligence into systems. All right, so you didn't come here for nothing. I did say there was supposed to be a hands-on session. Unfortunately, we don't have Wi-Fi, so I didn't bother with trying to give you instructions on how you can actually run this on your own right now. But I'll do the next best thing. I'm going to try and do it here in front of you to show you what I want to do. But let's talk a little bit about what I want to try and do. I put this up there so that you can gain some intuition about how this is happening. And what I want to try and do is basically a image classification or recognition. Is I want to see a picture, and I want to be able to say, this is the number that it is. Now, the thing that is interesting here, for those of you that might not be so geeky, as I am, is that pictures are actually numerical representations. When you think about pixels, right? And this is grayscale, and so you can see that the number, the darker it is, the higher the number is, and the lower the number, the lighter it is on the picture. So machines or computers need math. They need numbers to do computation. So behind the scenes, there's a representation of images as numbers. And what it's trying to do, if you think about it, is essentially trying to find a way to say, 8 looks like this typically. The algorithm I'm going to use is called support vector machine. And what a support vector machine is good for is when you have more features than sample data set. Support vector machine is a great model for you to use. And what it tries to do is it tries to classify it. So imagine if orange is like bad actor or spam email from the Nigerian prince or something like that. And I'm Nigerian, by the way, so that's where the joke is. And the blue is like not spam, right? It's from your boss, right? You need a way to kind of know the difference. And so what support vector machine tries to do is it tries to separate them, right? These are just, remember, they're numbers, right? So they're matrix representation, and it is represented somewhere on some dimension. So support vector machine tries to draw a line to say, hey, these are the bad actors, and these are the good actors. So that if you have a new point, and it falls on either side of the line, you can say, well, unfortunately, it fell on the bad actor side of things, so that means you're a bad actor. That's how classification is working, and that's what support vector machine is trying to do. But the more complex problem is, what line do I need to draw? What is the best line that best separates my training data, right? So there's this optimization that is going on under the hood to say, okay, I'm trying to draw a line, all right, good, this is the best line that I have. So just to give you some intuition, that's essentially what is happening there. And to tell you how simple, maybe I'm proclaiming too much. To tell you how simple it is for you to actually do something with this and be able to code this on your own, these are the only steps that you really need, right? I'm going to show you actually this working. But the idea is I just get an instance of a support vector machine. I get my data, right? I know Easy will give an earlier talk about comments, might not like this, on my methods about X and Y, but yes, I'm passing X and Y into this. But you're passing in your training data. Once it's trained, you can score it to see how well it's doing. And last, you just pass a new input and you say predict. This is it, just 4 steps, right? Now, the challenge is, like, remember what I talked about? At a point in time, you need to get into the discomfort zone. How do I get my data? How do I get it set? But if you want to start doing something, actually learning how to get this done, this is a good place to start. So let's go ahead and give this a try. And because I've tried this once, and in a previous conference, and the demo gods were not very good, what I did was I just went ahead and commented at the lines just to make it easy here. All right, so what I'm doing here, what you see here, essentially, can you guys, oh, you can't see that. Because why is that? All right, so let me do this. All right, let's try this out. Let's see this, see if this works here. Yeah, it's on a separate screen, but give me a second. Let me see. Ah, yes. All right, now I got to find where that screen. This is what happens when you use a Mac and you have like 10,000 windows. You know, you have that luxury. So let me just find where I am here. And, all right. Okay, cool. Can you guys see now? No, it's pretty small. All right, let me make it a little bigger. That works too. All right, cool. So what you see here is, you guys good? Everybody see this? Somewhat? All right, cool. So here at the top is a couple of libraries I'm using, and this is Python. And I'm importing matplotlib because I want to show you visually what those pictures look like. Because after you make your guess in terms of what the number is, right, in terms of predicting what the number is, we want to confirm if it's really the number. I'm using NumPy. NumPy is a Python library for mathematical computations. If you're using well, that's pandas, but NumPy really helps you kind of do like mathematical matrix because a lot of matrix stuff is involved, so that helps with that. So here, Scikit-Learn is Scikit-Learn that I talked about earlier. All I'm doing is I'm pulling in some data sets, I'm pulling in an instance of the support vector machine, a reference to it, and I have metrics. I'm not going to show anything about that in a second. The data set that it has inbuilt into it, because they had to keep the library small, they didn't use the whole MNIST data set. They got it's about 1,700 images, roughly 8 by 8. All right, so the first thing we do here is pretty straightforward. We just load the data, right? So pretty simple. I have my data sets, and I say load the data. So I have the digits now. And the next thing I want to do, and I do here, is essentially get me a classifier. Now, gamma and C are kind of like parameters. You can apply their defaults for them. But basically, what those variables are is essentially saying, how strict do you want to be in drawing a line, right? Do you want me to cover as many points as possible in the training data? Or do you want the points to be so far away from the actual line that I draw? So those are what those 2 variables are useful and good for. So you don't need to do that, but if you wanted to set, I just used this before. All right, so we have our classifier, right? We have our data, but now we want to take our data and we want to, because before we train it, we want to separate it into our training set and our test set. Our training set basically is what we're going to train our model on, right? Before we actually test to see how well our model does. And so in order for us to be able to manage this, what we did was I say, you know what? Of all my data set, I want you to get everything in my data set except the last 10. Save the last 10. I want to use the last 10 to test to see how well my model has been built, okay? So once I do that, and then here I basically say, okay, I want you to make the last 10 my test data, right? The X and the Y. This is the input, this is the output. If what is predicted matches it, then I know I did a pretty good job, right? And here is the training. Like if you talk about machine learning and training data, that is the one line, you know, CLF.fit. Now to do all this, I didn't have to explain linear algebra or calculus or doing that. If you wanted to do something with this, you're starting to do something against some intuition in terms of how to work or use this. And I've done the training there. I've been able to actually train the data. So all my data sets, except the last 10, I've passed in my input and output, and it's trained it. Remember the line I was telling you was trying to draw? So it's drawn that line between all the 10 classes that I have. If I wanted to, we can kind of see what this data looks like. Let's clear this out. So remember I talked about the fact that the number is actually like pixels, right? So this is just showing you that, yes, truly, they are matrices, right? This is the output that it's looking at. So the actual pictures is representing them as matrices. So we can comment that back. We don't need that. Is that okay to do easy? All right, let me clear this up. All right, so the next thing I want to do is I basically want to do a prediction. So I'm saying, well, I want you to get this test data. I want you to get this object or whatever it is, this matrix, and I want to pass it through my model. There's some reshaping that happens. Don't worry about that, line 28. Now I want you to predict what that number is. So it's taking that matrix and it's trying to predict what that number is. Remember, it's just seeing a bunch of matrix numbers. And so what happens here, let's go ahead and run it. So we don't know what that number is, right? We don't know what that test is. We're just picking like, hey, the second to the last, or the last, go from the back, go back to and pick a value there. We don't know what that number is, but we just pick the number from our test set. And so we go ahead and run that. Let's just do this. So the prediction here is that the number is a 9, right? It's predicting that based on how well I've studied your training data in terms of what a 9 could look like, I think this matrix or this input you've passed in, I believe is a 9. Now let's see if it actually got that right. So here all I'm doing is basically plotting, visualizing what the actual number is to actually get a sense of it. And I think I might need to, here we go. Shoot. It's 5 a.m. Give me a second. It's a 9. So here, what I've done essentially is, thank you. But what I've done essentially is, just to kind of walk through what we did real quick, is basically take a data set. Now imagine whatever data set this could be. It could be pictures of cats or pictures of dogs, right? Get them into a numerical representation and you pass them into a support vector machine. It does the training. It knows what the label is. It knows what the output is. And all we're doing here, after we've been able to do that on a character recognition, is be able to actually print to say that number is actually a 9. So let's get back to our presentation real quick. And hopefully, yes. All right, awesome. So that's just the line of code I just walked through. Now, what I'm hoping for is, after you've gone through the experience and actually been able to do this, maybe you can create a computer that can actually answer the ultimate question of life. I'll warn you ahead of time that the answer might be this. So, but I don't know if it's going to be true. But truly and sincerely, my intent is that by the end of this year, if it so interests you that you want to be a rock star in machine learning, to do some practical things, I think that you can really achieve this. The key things really to take away is the idea is you can take a top-down approach. You can pick a problem and you can say, what do I need to know? Learn things on a just-as-needed basis. I provided some resources. There's the orange sheet there that has information on the courses, the algorithms you need to know, and where you need to start. Thank you very much for coming. If you have any questions, I don't know if there are any questions in Slack. I'll be more than happy to take those. Thank you so much for coming. I really appreciate it.